A flash is a device used in photography producing a flash of artificial light at a color temperature of about 5500 K to help illuminate a scene. A major purpose of a flash is to illuminate a dark scene. Other uses are capturing quickly moving objects or changing the quality of light. Flash refers either to the flash of light itself or to the electronic flash unit discharging the light. Most current flash units are electronic, having evolved from single-use flash bulbs and flammable powders. Modern cameras often activate flash units automatically. Flash units are commonly built directly into a camera. Some cameras allow separate flash units to be mounted via a standardized accessory mount bracket. In professional studio equipment, flashes may be large, standalone units, or studio strobes, powered by special battery packs or connected to mains power. They are either synchronized with the camera using a flash synchronization cable or radio signal, or are light-triggered, meaning that only one flash unit needs to be synchronized with the camera, and in turn triggers the other units, called slaves. Types of flash. Flash lamp. Studies of magnesium by Bunsen and Roscoe in 1859 showed that burning this metal produced a light with similar qualities to daylight. The potential application to photography inspired Edward Sonstadt to investigate methods of manufacturing magnesium so that it would burn reliably. For this use, he applied for patents in 1862 and by 1864 had started the Manchester Magnesium Company with Edward Mellor. With the help of engineer William Mather, who was also a director of the company, they produced flat magnesium ribbon, which was said to burn more consistently and completely, so giving better illumination than round wire. It also had the benefit of being a simpler and cheaper process than making round wire. Mather was also credited with the invention of a holder for the ribbon, which formed a lamp to burn it in. A variety of magnesium ribbon holders were produced by other manufacturers, such as the pistol flashmeter, which incorporated an inscribed ruler that allowed the photographer to use the correct length of ribbon for the exposure they needed. The packaging also implies that the magnesium ribbon was not necessarily broken off before being ignited. An alternative to ribbon was flash powder, a mixture of magnesium powder and potassium chlorate, introduced by its German inventors Adolf Maether and Johannes Giedicke in 1887. A measured amount was put into a pan or trough and ignited by hand, producing a brief brilliant flash of light, along with the smoke and noise that might be expected from such an explosive event. This could be a life-threatening activity, especially if the flash powder was damp. An electrically triggered flash lamp was invented by Joshua Lionel Cowan in 1899. His patent describes a device for igniting photographer's flash powder by using dry cell batteries to heat a wire fuse. Variations and alternatives were touted from time to time, and a few found a measure of success in the marketplace, especially for amateur use. In 1905, one French photographer was using intense non-explosive flashes produced by a special mechanized carbon arc lamp to photograph subjects in his studio. But more portable and less expensive devices prevailed. On through the 1920s, flash photography normally meant a professional photographer sprinkling powder into the trough of a T-shaped flash lamp, holding it aloft, then triggering a brief and harmless bit of pyrotechnics. Flash bulbs. The use of flash powder in an open lamp was replaced by flash bulbs. Magnesium filaments were contained in bulbs filled with oxygen gas and electrically ignited by a contact in the camera shutter. Manufactured flash bulbs were first produced commercially in Germany in 1929. Such a bulb could only be used once, and was too hot to handle immediately after use. But the confinement of what would otherwise have amounted to a small explosion was an important advance. A later innovation was the coating of flash bulbs with a plastic film to maintain bulb integrity in the event of the glass shattering during the flash. A blue plastic film was introduced as an option to match the spectral quality of the flash to daylight balanced color film. Subsequently, the magnesium was replaced by zirconium, which produced a brighter flash. Flash bulbs took longer to reach full brightness and burned for longer than electronic flashes. Slower shutter speeds were used on cameras to ensure proper synchronization. Cameras with flash sync triggered the flash bulb a fraction of a second before opening the shutter, allowing faster shutter speeds. A flash bulb widely used during the 1960s was the Press 25, the in-diameter flash bulb often used by newspapermen in period movies, usually attached to a press camera or a twin-lens reflex camera. Its peak light output was around 1 million lumens. Other flash bulbs in common use were the M series, M2, M3 etc., which had a small metal bayonet base fused to the glass bulb. The largest flash bulb ever produced was the GE Mazda No. 75, initially developed for nighttime aerial photography during World War II. The all-glass AG-1 bulb was introduced in 1958. Eliminating both the metal base, and the multiple manufacturing steps needed to attach it to the glass bulb, cut the cost substantially compared to the larger M-series bulbs. The AG-1 had a faster ignition time, so it could be used with X-sync below 1/30th of a second, while most bulbs require a shutter speed of 1/15th on X-sync to keep the shutter open long enough for the bulb to ignite and burn. Flash cubes, Magicubes and flip flash. In the late 1960s, Kodak improved their Instamatic camera line by replacing the individual flash bulb technology with the flash cube. A flash cube was a single-use module with 4 flash bulbs mounted at 90 degrees from the others in its own reflector. For use, it was mounted on a swivel mechanism atop the camera that also provided an electrical connection to the shutter release and a battery inside the camera. After each exposure, the film advance mechanism also rotated the flash cube 90 degrees to a fresh bulb. This arrangement allowed the user to take 4 images in rapid succession before inserting a new flash cube. The later Magicube retained the 4-bulb format, and was superficially similar to the original flash cube. However, the Magicube did not require electrical power. Each bulb was set off by a plastic pin in the cube mount that released a coax spring wire within the cube. This wire struck a primer tube at the base of the bulb, which contained a fulminate, which in turn ignited shredded zirconium foil in the flash. Magicubes could also be fired by inserting a thin object, such as a key or paper clip, into one of the slots in the bottom of the cube. Flash cubes and Magicubes look similar but are not interchangeable. Cameras requiring flash cubes have a round socket and a round hole for the flash cube's pin, while those requiring Magicubes have a round shape with protruding studs and a square socket hole for the Magicube's square pin. The Magicube socket can also be seen as an X, which accounts for its alternate name, the X-cube. Other common flash bulb-based devices were the flash bar and flip flash, which provided about 10 flashes from a single unit. Electronic flash was developed after flash bulbs, and eventually superseded them as prices came down. Flash bulbs are virtually obsolete. A typical electronic flash unit has electronic circuitry to charge a high-capacity capacitor to several hundred volts. When the flash is triggered by the shutter's flash synchronization contact, the capacitor is discharged almost instantaneously through a flash tube, producing a flash of very brief duration almost instantaneously. Synchronization of full flash brightness with maximum shutter opening was problematic with bulbs which took an appreciable time to ignite and reach full brightness. Electronic flash does not have these difficulties. Electronic flash units are sometimes called speedlights or strobes in the USA. Simple electronic flash units are often mounted on or near the camera. Many inexpensive cameras have an electronic flash unit built in. Some lenses have built-in flashlights for shadow-free macro photography, but there are also accessory ring flashes available. In a photographic studio, more powerful and flexible studio flash systems are used. They usually contain a modeling light, an incandescent light bulb close to the flash tube. The continuous illumination of the modeling light lets the photographer visualize the effect of the flash. A system may comprise multiple synchronized flashes for multi-source lighting. The strength of a flash device is often indicated in terms of a guide number designed to simplify exposure setting. The energy released by larger studio flash units, such as monolights, is indicated in watt-seconds. High-speed flash and air-gap flash is a high-voltage device that discharges a flash of light with an exceptionally short duration, often much less than 1 microsecond. These are commonly used by scientists or engineers for examining extremely fast-moving objects or reactions. Famous for producing images of bullets tearing through light bulbs and balloons. An example of a process by which to create a high-speed flash is exploding wire method. Multi-flash A camera that implements multiple flashes can be used to find depth edges or create stylized images. Such a camera has been developed by researchers at the Mitsubishi Electric Research Laboratories. Successive flashing of strategically placed flash mechanisms results in shadows along the depths of the scene. This information can be manipulated to suppress or enhance details or capture the intricate geometric features of a scene, to create a non-photorealistic image form. Such images could be useful in technical or medical imaging. Flash intensity. Unlike flash bulbs, the intensity of an electronic flash can be adjusted on some units. To do this, smaller flash units typically vary the capacitor discharge time, whereas larger units typically vary the capacitor charge. Color temperature can change as a result of varying the capacitor charge, thus making color corrections necessary. Due to advances in semiconductor technology, some studio units can now control intensity by varying the discharge time and thereby provide consistent color temperature. Flash intensity is typically measured in stops or in fractions. Some monolights display an EU number, so that a photographer can know the difference in brightness between different flash units with different watt-second ratings. EU 10.0 is defined as 6,400 watt-seconds, and EU 9.0 is one stop lower, i.e., 3,200 watt-seconds. Flash duration. Flash duration is commonly described by two numbers that are expressed in fractions of a second. T1 is the length of time the light intensity is above 0.1 of the peak intensity. T5 is the length of time the light intensity is above 0.5 of the peak intensity. For example, a single flash event might have a T5 value of 1/1200th and T1 of 1/450th. These values determine the ability of a flash to freeze moving subjects in applications such as sports photography. In cases where intensity is controlled by capacitor discharge time, T5 and T1 decrease with decreasing intensity. Conversely, in cases where intensity is controlled by capacitor charge, T5 and T1 increase with decreasing intensity due to the non-linearity of the capacitor's discharge curve. Flash LED used in phones. High-current flash LEDs are used as flash sources in camera phones. Although they are not yet at the power levels to equal xenon flash devices in still cameras, the major advantages of LEDs over xenon include low voltage operation, higher efficiency, and extreme miniaturization. The LED flash can also be used for illumination of video recordings or as an autofocus assist lamp in low light conditions. Focal plane shutter synchronization. Electronic flash units have compatibility issues with focal plane shutters. Focal plane shutters expose using two curtains that cross the sensor. The first one opens and the second curtain follows it after a delay equal to the nominal shutter speed. A typical modern focal plane shutter takes about 1/200th to cross the sensor, so at exposure times shorter than this only part of the sensor is uncovered at any one time. Electronic flash can have durations as short as 50 microseconds, so at such short exposure times only part of the sensor is exposed. This limits the shutter speed to about 1/200th when using flash. In the past, slow-burning single-use flash bulbs allowed the use of focal plane shutters at maximum speed because they produce continuous light for the time taken for the exposing slit to cross the film gate. If these are found, they cannot be used on modern cameras because the bulb must be fired before the first shutter curtain begins to move. The X-Sync used for electronic flash normally fires only when the first shutter curtain reaches the end of its travel. High-end flash units address this problem by offering a mode, typically called Sync or HSS, which fires the flash tube multiple times during the time the slit traverses the sensor. Such units require communication with the camera and thus dedicated to a particular camera make. The multiple flashes result in a significant decrease in guide number, since each is only a part of the total flash power, but it's all that illuminates any particular part of the sensor. In general, if S is the shutter speed, and T is the shutter traverse time, the guide number reduces by square root St. For example, if the guide number is 100, and the shutter traverse time is 5 milliseconds, and the shutter speed is set to 1/2000th, the guide number reduces by a factor of square root 0.55, or about 3.16, so the resultant guide number at this speed would be about 32. Current flash units frequently have much lower guide numbers in HSS mode than in normal modes, even at speeds below the shutter traverse time. For example, the Mecca Blitz 58AF-1 digital flash unit has a guide number of 58 in normal operation, but only 20 in HSS mode, even at low speeds. Technique. As well as dedicated studio use, flash may be used as the main light source where ambient light is inadequate, or as a supplementary source in more complex lighting situations. Basic flash lighting produces a hard, frontal light unless modified in some way. Several techniques are used to soften light from the flash or provide other effects. Softboxes, diffusers that cover the flash lamp, scatter direct light and reduce its harshness. Reflectors, including umbrellas, flat white backgrounds, drapes and reflector cards are commonly used for this purpose. Bounce flash is a related technique in which flash is directed onto a reflective surface, for example a white ceiling or a flash umbrella, which then reflects light onto the subject. It can be used as fill flash or, if used indoors, as ambient lighting for the whole scene. Bouncing creates softer, less artificial-looking illumination than direct flash, often reducing overall contrast and expanding shadow and highlight detail, and typically requires more flash power than direct lighting. Part of the bounced light can be also aimed directly on the subject by bounce cards attached to the flash unit, which increase the efficiency of the flash and illuminate shadows cast by light coming from the ceiling. It's also possible to use one's own palm for that purpose, resulting in warmer tones on the picture, as well as eliminating the need to carry additional accessories. Fill flash or fill-in flash describes flash used to supplement ambient light in order to illuminate a subject close to the camera that would otherwise be in shade relative to the rest of the scene. The flash unit is set to expose the subject correctly at a given aperture, while shutter speed is calculated to correctly expose for the background or ambient light at that aperture setting. Secondary or slave flash units may be synchronized to the master unit to provide light from additional directions. The slave units are electrically triggered by the light from the master flash. Many small flashes and studio monolights have optical slaves built in. Wireless radio transmitters, such as pocket wizards, allow the receiver unit to be around a corner, or at a distance too far to trigger using an optical sync. Strobe. Some high-end units can be set to flash a specified number of times at a specified frequency. This allows action to be frozen multiple times in a single exposure. Colored gels can also be used to change the color of the flash. Correction gels are commonly used, so that the light of the flash is the same as tungsten lights or fluorescent lights.